Right. So, very good afternoon to you all. I welcome you all for today's EMF session. Um, uh, I have started one very important topic, EM wave propagation in different media. So, in my last session, I have given the introduction and given the introduction for EM wave propagation in different media, and also I have discussed how to express Maxwell's equations in time harmonic form. Right. So, as you can see here, Maxwell's equations in time harmonic form. So, this is the Maxwell's equation in time harmonic form, and this one, and this one, and this one are the Maxwell's equations in time harmonic form. Right. We have been come across those. The only thing is for time harmonic form, right? The term dou by dou t is replaced with j omega, right? Dou by dou t is replaced with j omega. Similarly, dou square by dou t square is replaced with what? J omega square, right? Dou by dou t is j omega, and dou square by dou t square is j omega square, right? So these 2 points you remember, and then I have given the introduction for EM wave propagation in different media, and the characteristics of different media I have given, right? So free space, lossless dielectric, lossy dielectric, and good conductor, and their characteristics in terms of conductivity, permittivity, permeability, and those characteristics I have given. And I have started discussing wave propagation in free space, right? So wave propagation in free space characteristics are sigma is equal to 0, epsilon is equal to epsilon naught, mu is equal to mu naught, right? So considering these characteristics and modifying Maxwell's equations accordingly, we will get this one, right? So these are the 4 equations 1 to 4 are the modified equations of Maxwell's according to free space conditions. Right? And equations 1, 2, 3, and 4, we have used these 4 Maxwell's equations to describe wave propagation in free space. So from equation 1, applying curl on both sides, right? Applying curl on both sides and simplifying, we will get equation 5, and the equation 6 we will get. So equation 6 is the wave equation in free space in terms of electric field, and we can also determine wave equation in terms of magnetic field by taking equation 2. So taking equation 2, so this is equation 2, right? So taking equation 2 and applying curl on both sides and simplifying, we'll get equation 7. And equation 7 is the wave equation in free space in terms of magnetic field. And the general form of wave equation is equation 8. Equation 8 is the general form of wave equation. So therefore, comparing equation 7 and equation 8, 1 by v square is equal to mu naught epsilon naught, and v square is equal to 1 by mu naught epsilon naught. V naught is equal to 1 by root mu naught epsilon naught, and substituting mu naught value and epsilon naught value, So these are the constant values in free space, mu naught and epsilon values in free space, and we will get velocity of EM wave in free space. So velocity of EM wave in free space is 3 into 10 power 8 meters per second, and which is equal to the velocity of the light. So therefore EM wave travels with a velocity which is equal to velocity of light in free space, right? So up to here we have discussed in our last class, right? And wave equation, let us say equation 6, right? So equation 6, let me consider equation 6. Equation 6 is the wave equation in terms of electric field, right? So from equation 6, del square E bar is equal to mu naught epsilon naught dou square E bar by dou d square, right? So this is equation 6, and which is a wave equation in terms of electric field, right? Expressing it in phasor form or uh, time harmonic form, right? So expressing the above equation in time harmonic form, what will get? Time harmonic form delta square E bar S ES. So what is ES? ES is the phasor form of E, and mu naught epsilon naught J omega square E bar S, right? Since dou square by dou d square is J omega square, right? So just now I have explained, right? So dou square by dou t square can be replaced with J omega square, right? So simplifying this, what will get? Delta square ES is equal to J square omega square mu naught epsilon naught ES bar, and this can be written as delta square ES is equal to gamma square ES bar, right? So this is wave equation I have written in terms of gamma, right? So where gamma is propagation constant, right? Propagation constant, and where gamma is equal to alpha plus j beta, right? And where alpha is attenuation constant, and beta is phase constant. Attenuation constant in the sense it will give how amplitude varies, right? Variation in amplitude of the wave. And beta phase constant in a sense it will give how phase of the wave is varying, right? So any wave can be described like that, right? So wave can be defined in terms of amplitude of the wave and in terms of phase, right? Phase of the wave, right? So therefore alpha and beta, attenuation constant and phase constant, right? And gamma square is equal to J square omega square mu naught epsilon naught, right? Comparing this one. So here this J square, right? So this term So j square omega square mu naught epsilon naught is nothing but gamma square, right? So therefore equating these two, right? Equating these two in comparison, and we will get gamma is equal to j omega root mu naught epsilon naught, right? Gamma is equal to j omega root mu naught epsilon naught, right? So if you compare with this here, right, gamma, and which is equal to alpha plus j beta, right? So if you compare this, we will get alpha is equal to 0, right? And beta is equal to omega root mu naught epsilon naught, right? Beta is equal to root mu naught epsilon naught. Attenuation constant is 0, right? Alpha is 0 means attenuation constant is 0. Attenuation constant is 0 in the sense what? There is no attenuation, right? So there is no attenuation in the sense what? There are no losses in the amplitude, right? There are no losses in the amplitude in free space. When wave is propagating in free space, and there will not be any losses in the amplitude. And phase, right? Phase varies like this. The beta is equal to omega root mu naught epsilon naught, and beta is equal to omega by v naught, right? Since v naught is equal to 1 by root mu naught epsilon naught, right? So here we have defined. So this is the velocity, right? So velocity of the wave v naught is equal to 1 by root mu naught epsilon naught, right? So therefore beta is equal to omega by v naught, right? So this is the phase constant. So attenuation constant alpha is 0 and phase constant beta is equal to omega by v naught, right? So phase constant is directly proportional to frequency and is inversely proportional to velocity, right? So with this we have completed how many here, right? So in the last class I have given what we are going to discuss in this, right? So wave equation in free space, in the last class I have derived it: propagation constant, phase constant, attenuation constant, and velocity of EM wave in free space. So these five I have discussed. And coming to intrinsic impedance, right? So intrinsic impedance of free space, uh, in detail I will discuss later, but you just remember this. I will derive the equation. Intrinsic impedance of free space, right? I will derive later, but for time being you just remember eta naught is the intrinsic impedance, right? And impedance, so which is the ratio between E and H, right? Which is the ratio between E and H, electric field and magnetic field, right? So because electric field, so what are the units of electric field? Volts per meter. And what are the units for magnetic field? Amperes per meter. So therefore volt per ampere, right? Volt per ampere, right? That means V by I. So it is nothing but impedance. V by I is nothing but impedance. So therefore E by H, the ratio E by H will gives us the intrinsic impedance of the wave, intrinsic impedance, and which is given by root over mu naught by epsilon naught, right? Mu naught by epsilon naught. So this expression I will derive later. You just remember this. So this is equal to root over 4 pi into 10 power minus 7 divided by 10 power minus 7 by 36 pi, right? So this is epsilon naught value, and if you simplify this, you'll get 377 ohms or 125 ohms, right? So this is the impedance, right? So this is the impedance of a wave in free space, right? Intrinsic impedance of the wave in free space is 377 ohms or 120 pi ohms, right? So very important. And wavelength, let me discuss wavelength also. Wavelength. So what is meant by wavelength? Wavelength is lambda, right? Wavelength is lambda, right? How do you define lambda? Lambda is the distance, right? The distance that the wave travels, right? The distance that the wave travels in a time t with a velocity v. And so, for example, so this is the wave, and time t for one cycle, time t. The distance traveled by the wave, right? The distance lambda traveled by the wave in time t with a velocity v, right? So the distance lambda is I mean the distance lambda traveled by the wave in time t with a velocity v, right? Then how do you relate all these three parameters? Distance lambda is equal to velocity into time, right? Distance traveled by the wave is nothing but wavelength. So lambda is distance meters, and which is equal to velocity meters per second and time second, right? So second and second, and we'll get meter. So therefore, which is equal to lambda distance, right? So distance is measured in terms of meters. So therefore, lambda is equal to vt, and lambda is equal to v by f, right? Or c by f, right? So sometimes in some cases it is denoted as c, right? C is the velocity of the wave or the light. So lambda is equal to v by f, right? Because time t is equal to 1 by f, right? So this can be written further like this: 2 pi v by 2 pi f, right? Multiplying and dividing with 2 pi, and this is equal to 2 pi v by omega, right? 2 pi v by omega, and this is equal to 2 pi by omega by v, right? Lambda is equal to 2 pi by omega by v, right? For free space, it is v naught, right? For free space it is v naught. So omega by v naught. So what is omega by v naught? So omega by v naught is beta, phase constant, right? Omega by v naught is phase constant, right? So therefore this can be written as lambda is equal to 2 pi by beta, right? Lambda is equal to 2 pi by beta. So this is how we can relate, right? Relationship between lambda and beta, right? So this is how we can relate wavelength lambda and phase constant beta, right? So this is about wave propagation in free space, right? So very simple. So in this we have discussed all these, right? So in free space we have discussed all this. Wave equation I have derived, and I have defined propagation constant, phase constant, detonation constant, and velocity of EM wave in free space, and intrinsic impedance, right? So I have derived EM wave equation directly by considering Maxwell's equations, and simplifying Maxwell's equations, and following a certain procedure, I have defined all the related parameters, right? So this is about free space, EM wave propagation in free space, right? And next one, lossless dielectric, right? So lossless dielectric. So what is the difference here between lossless dielectric and the free space? Here sigma is equal to 0 and sigma is equal to 0, right? Epsilon is equal to epsilon naught, and epsilon is equal to epsilon r epsilon naught. Mu is equal to mu naught, mu is equal to mu naught mu r, right? Mu naught mu r, right? So therefore the only difference here is epsilon r not equal to 1 and mu r not equal to 1. It is greater than 1, right? It is greater than 1. So therefore free space and lossless dielectric, they are the same, right? Free space and lossless dielectric, they are the same. The only thing is here, right? So here for free space, mu naught here, and that is mu, right? Mu naught is mu, right? So wherever mu naught is there, in the entire derivation, wherever mu naught is there, you remove naught, right? You remove naught. So or you place it mu, and similarly wherever epsilon naught is there, you place epsilon, right? So wherever mu naught is there, it is mu, and wherever epsilon naught is there, it is epsilon, and rest of the things are same, right? So therefore this procedure, this entire procedure is same, right? Everything, all the steps are same, right? And here velocity, so velocity v, right? For lossless dielectric, right? So for lossless dielectric v, I have removed naught, right? And which is equal to root mu epsilon, right? Instead of mu naught epsilon naught, it is simply mu epsilon, right? And which is equal to 1 by root mu r mu naught epsilon or epsilon naught. So this is equal to 1 by root mu r epsilon r and root mu naught epsilon naught, right? So therefore 1 by root mu naught epsilon naught is v naught, v naught by root mu r epsilon r, right? So v is equal to v naught by root mu r epsilon, right? So this is the velocity. So this is the expression for velocity for lossless dielectric media, right? And so from this what we can say, velocity in lossless dielectric medium is less than here, right? So from this we can see that V is less than V naught, right? V is less than V naught, right? So therefore we can say that velocity of the wave in a lossless media, I mean lossless dielectric media, is less than velocity of the light, right? So velocity of the wave in a lossless media is less than velocity of the light, and rest of the things are same, right? Everything is same, and here alpha is 0, right? And beta is equal to omega root mu epsilon, right? Omega root mu epsilon, right? So this is beta, omega root mu epsilon. Now it is not mu naught epsilon naught, this mu epsilon, right? And beta is equal to omega by V, right? Omega by V. And intrinsic impedance is equal to root mu by epsilon, right? Root mu by epsilon. So this is equal to 377 root mu r by epsilon r, right? Mu r by epsilon r. So this is the intrinsic impedance, right? So this is all about the lossless dielectric media, right? So we have completed lossless dielectric media also, right? So one shot, two boards. So free space and lossless dielectric media, right? So two we have completed, right? So if you are well aware with free space, lossless dielectric media is very similar, right? So that's it. And coming to lossy dielectric media, so this is very important, lossy dielectric media, right? So let us move on to a new page. EM wave propagation in lossy dielectric media, right? So EM wave propagation in a lossy dielectric media, right? So let us discuss about this, right? So lossy dielectric media, what are the characteristics? Lossy dielectric medium is characterized by sigma not equal to 0, mu is equal to mu or mu naught, epsilon is equal to epsilon or epsilon naught, right? Right? So these are the characteristics, am I right? So sigma not equal to 0, epsilon is equal to epsilon or epsilon naught, mu is equal to mu naught mu r, right? So these are the characteristics. according to the characteristics, we need to modify Maxwell's equations, right? So del cross E bar is equal to minus dou B by dou T, right? Or del cross ES bar is equal to minus J omega mu HS bar, right? Since dou by dou T is J omega and B is equal to mu H bar, right? So this is first Maxwell's equation. And second one, del cross H bar is equal to J. What is J? Sigma E bar plus dou D by dou T, right? J is sigma E bar, right? So in my last class I have discussed with this one, right? So J is equal to sigma E bar, right? So this one, J is equal to sigma E bar on this one. So I said that this is the Ohm's law for field theory, right? J is equal to sigma E is the Ohm's law for field theory, right? So J plus dou D by dou T. So J in the sense sigma E bar plus dou D by dou T, or del cross HS bar is equal to sigma ES bar plus J omega epsilon E bar S, right? Since dou by dou T is J omega and D is equal to epsilon E bar, right? So here sigma is not equal to 0, right? So that you need to remember, sigma not equal to 0, right? Earlier what we have done, sigma is 0, right? Sigma is 0, so therefore J is 0, right? Sigma is 0, therefore J is 0, and then this equation becomes like this. Here the first term on right hand side we have equated to 0, right? So we have this one, but whereas here in this case sigma not equal to 0, right? Sigma not equal to 0, so that is only the difference, right? And the remaining two, they remain same, right? Del dot ES bar is equal to 0 and del dot HS bar is equal to 0. Remaining two, they are the same. So let us say this is equation 1 and this is equation 2 and this one is equation 3 and this one equation 4, right? So here I have written Maxwell's equations directly in time harmonic form, right? Directly in time harmonic form, right? So earlier I have taken in time varying field, time varying form, right? Initially I have taken in time varying field and later on, right? So at what point, at this point, right? So at this point I have converted into time harmonic field, right? At this point I have converted into time harmonic field, but whereas here in this case at the starting itself I have considering time harmonic fields, time harmonic Maxwell's equation. Even for previous topic also you can take right, directly you can take the okay. Is my voice audible and is my screen visible? Okay, right? So these are the four Maxwell's equations for lossy dielectric media, right? Lossy dielectric media, right? So let us follow the same procedure, right? Thank you. Let us follow the same procedure. From equation 1, so what is equation 1? Del cross Es bar is equal to what is that? Minus j omega mu hs bar, right? Applying curl on both sides. Applying curl on both sides. Therefore, curl of Es bar is equal to minus j omega mu del cross hs bar, right? And let us say this is equation 5. Okay, not this one. Further, let us simplify. Delta dot Es bar minus delta square Es bar is equal to minus j omega mu delta cross hs bar. And let us say this is equation 5, right? So in equation 5, here delta dot Es bar is 0 and delta cross hs bar is equation 2, right? So substituting those here, right? Substituting those here, what we'll get? Minus delta square Es bar is equal to minus j omega mu sigma Es bar plus j omega epsilon Es bar, right? Since from equations 2 and 3, right? From equations 2 and 3 here, right? So from equation 2, del cross hs is equal to sigma es plus j omega epsilon es, and from equation 3, del dot es is equal to 0, right? So substituting those and simplifying this, delta square es bar is equal to what we'll get? J sigma omega mu minus omega square mu epsilon, right? Multiplying, I'm multiplying, right? So this one into this one and this one into this one, right? Multiplying and taking es common, right? So es is the common term in both the cases. Am I right? Am I doing right? So j sigma omega mu and j into j is j square, and j square is equal to minus 1, right? So therefore here minus omega square mu epsilon yes, right? So this we will get, right? And delta square es is equal to gamma square es bar, right? So this is the wave equation, right? So wave equation in terms of electric field, right? Wave equation in terms of electric field, right? You can also determine wave equation in terms of magnetic field. You'll get same, that I'm not going to do here, right? So here in this, right? So here, if you compare these two, so this term, right? This term is nothing but gamma square, right? So therefore, gamma square, where gamma square is equal to what? Minus omega square mu epsilon plus j sigma omega mu, right? Sigma omega mu. And alpha plus j beta whole square is equal to minus omega square mu epsilon plus j sigma omega mu, since gamma is equal to alpha plus j beta. Let us say this is equation 6. So because equation 6 we will use later, right? And this is a plus b whole square form. So a square plus b square, j beta square. So j square is minus 1. Therefore, minus beta square plus 2j alpha beta is equal to minus omega square mu epsilon plus j sigma omega, right? Therefore, here you can see, so this is the real part, right? So this is the real part, and on right hand side this is the real part, right? And this one is the imaginary part, and this one is the imaginary part, right? So therefore, equating real part, we'll get alpha square minus beta square is equal to minus omega square mu epsilon, and this is equation 7, right? So we have alpha square minus beta square, right? um, if I want alpha and beta, right, attenuation constant and phase constant, right, my aim is to determine those two, right? So therefore, as I have alpha square minus beta square, if I can have alpha square plus beta square, right, I have alpha square minus beta square, if I can have alpha square plus beta square, I can determine alpha and beta, right? Comfortably I can determine alpha and beta, right? So I have alpha square plus beta square, alpha square minus beta square I have, right? If I can have alpha square plus beta square, how I can determine alpha and beta? If you add these two, right? If you add these two, you will get 2 alpha square is equal to something, and from this you will get alpha. And if you subtract, right? If you subtract these two, you will get beta, right? You will get beta. So therefore, addition will get alpha, and subtracting will get beta, right? So now, how to get alpha square plus beta square? That is from equation 6, right? So from equation 6, so what we have, alpha, once again I'm writing here, is equal to minus omega square mu epsilon plus j sigma omega mu, right? So find out the magnitude, mod, right? On both sides, find out the mod, apply mod, right? Apply mod. So minus omega square mu epsilon plus j sigma omega mu, right? Apply mod. So mod in the sense what? Square root of real part square plus imaginary part square, right? So therefore, square root of real part square plus imaginary part square already whole square is there, and this is equal to square root of real part square plus imaginary part square, right? So if you simplify this, alpha square plus beta square is equal to root over minus omega square mu epsilon whole square plus sigma omega mu whole square, and this is equation 8, right? So therefore equation 7 is alpha square minus beta square, and equation 8 is alpha square plus beta square. So therefore solving equation 7 and 8, add first add equation 7 and 8, you will get alpha, and then subtract, you will get beta, right? So expression for the attenuation constant and expression for the phase constant you will get, right? So that we will do in the next class, right? So I hope you understood the topic. So is it clear today's class? Is today's class clear? Please respond.